All right, so we are actually going to start trig, and we're going to start with some background stuff. Some of you may already have this if you had a solid lesson in this in geometry. Some of you may not. I know if you were in integrated math, you guys were rushing through some things, so you may or may not have seen this because integrated was combined with algebra 2. There's nothing wrong with that. Again, I'm going to go back just a little bit, so we're going to cover stuff that should have been covered in geometry first, just so that we make sure we all know it. If you have a good understanding of this and you want to try to skip the video, feel free. I won't be offended by that. But we're going to go through your assignment tonight. Actually has 4 exercises on Khan Academy. They're fairly basic, but just be aware of that. So I'm going to go through how to find sine, cosine, and tangent of right triangles, and then a couple of examples of manipulating it just a little bit. So we're going to start with the basic triangle. Okay, it's going to always be right angles right now. We will deal with triangles that don't have right angles later, but starting out, okay, we're going to label this A, B, C. I'm also going to label this angle here, angle theta. Okay, that's very common in trig. We will see that angle a lot. We use the Greek letters for the most part. Now, to find sine, cosine, and tangent of pieces of these of the triangle, I want you to memorize this little saying here. And honestly, I still remember it from when I was in trig. I didn't, and this helps a lot. If you can remember this little. Oops. It's called SOHCAHTOA. And when I was in trig, my teacher gave me this big long story about an Indian named SOHCAHTOA. You can probably look it up if you'd like, but that honestly didn't help me remember anything. So, but what this means is this says the sine, okay, the S stands for sine, so the sine of theta is equal to the opposite over the hypotenuse. Okay, so if I'm looking for the sine of this angle theta, I would look for the opposite side, these are sides, not angles, okay, over the hypotenuse. Right? Now if I want the cosine of theta, okay, I would go adjacent. Adjacent means right next to, over hypotenuse. Okay, so here's angle A. Adjacent is going to be the one that's sitting next to the angle over the hypotenuse. And the tangent has nothing to do with the hypotenuse at all. Right? It is opposite over adjacent. So if you'll notice, okay, when we say the sine, so S-O-H, opposite over hypotenuse, ka, say adjacent over hypotenuse, toa, opposite over adjacent. Okay, so if you can remember this phrase, you do not have to memorize these formulas because that's how you will have that phrase. I will not be giving you these formulas on any sort of quiz or test, okay? You have to memorize this. There are some things in trig that I require you to memorize. There are other things that you do not. This is one of those. You have to have this memorized. In fact, I dare say on the homework quiz, I might just ask you to fill in this chart for me. So this is really important to have memorized. Okay, so a couple of things about angles, if we've forgotten from geometry. Okay, angle theta can also be written as angle A. It could also be written as angle BAC. Okay, the angle that's the letter that's in the middle is always the angle that it is. It can also be written as angle CAB. Now, there's a lot of things I really like about Khan Academy. I do not like the way they write angles. Okay, they write them in this form. All right, so just be aware of that. You know, as you're answering questions and things like that, it's always the letter in the middle that it's looking for. So, all right, moving on. So now we have our phrase SOHCAHTOA. We have all of the formulas. Again, would be important to memorize. All you really need to learn is this phrase. And as long as you know what the O and the H mean and the triangle, how it looks, you should be fine. Okay, so let's do some examples of how we use this. Again, very basic stuff today. We're not going into any detail. I have a triangle and a right angle. Okay, we're going to call this A, B, C. Okay, and we're going to say this is 2, this is 3, and this is 5. Okay, now I know Con uses the, the CAB or the CBA or something like that. I'm not going to do that. I'm just going to call it angle A, angle B, or angle C. So if I want to find, say, the sine of angle A, what do I need to do? Now, if you remember the sine, it's so so it's so, S-O-H. So it's the opposite over the hypotenuse. Okay, now I'm going to show you something fun with this. Let's say I find the cosine of angle A. All right, cosine is so C-A-H. Okay, so adjacent. So now I'm oh no, sorry, I was looking wrong. I want to find the cosine of angle B. Okay, cosine of angle B. So the adjacent is now 2 over 5. So if you'll notice, the sine of angle A is the same thing as the cosine of angle B. That'll be important when we're doing proofs, but that's not for a while. Okay, now let's find, say, the tangent of angle A. Okay, the tangent of angle A, remember tangent is TOA, okay, opposite over adjacent. So if we have angle A here, the opposite is 2, the adjacent is 3, so it's 2 over 3. All right, so that's the first part of your homework. Keep in mind that Con will call this, they would call this angle BAC or something like that. They don't call it angle A. So, all right, let's do another example. So a lot of times when we are dealing with trig and triangles, we're going to end up with a lot of square roots. So, and irrational numbers, get used to them, okay? We have something called the unit circle coming up, which has all kinds of fractions and pies and square roots and all that kind of stuff. So just be comfortable. You have to be comfortable using these kind of numbers. So we're going to do this again. I'm going to use 2 and 3 once more. But instead of having this be 5, we're going to make this the square root of 5. So let's say I wanted to find the cosine of angle B. Now cosine, remember, is so cos adjacent over hypotenuse. So the adjacent here is 2, and the hypotenuse is the square root of 5. So it's 2 over the square root of 5. Now, you cannot leave these fractions as irrational. You cannot leave square roots in the denominator. It's called rationalizing the denominator. If you don't know how to do that, I would Google it. You should know that by now. I'm not going to teach that. But so if I rationalize this denominator, I end up with 2 square root of 5 over 5. And again, it's a skill that you should already know. So if you want to come after school and work with me too, I'm willing to do that. Alrighty, so now let's find the sine of angle B. Okay, so sine is so, S-O-H, okay? So the sine of angle B is 3 over the square root of 5. Can't leave a square root in the denominator, so we're going to go 3 square root of 5 over 5. Alright, so that's the first part of your homework, is dealing with those kind of problems. That's probably the easier 4. No, there's 2 of them. There's 2 that look like this and 2 of the next one. Alright, so the next one's going to give us a triangle. And it's going to look like this. Always right angle. So I have A, B, C. I apologize for the noise. There's a class underneath me right now. I hope it's not showing up on the video. Okay, so it's going to give me something like this, and then it's going to say, it's going to give me information about the sides. So the sine of B, square root of 5 over 5. Cosine of B is 2 square root of 5 over 5. And the tangent of B is 1 over 2. Now I would recommend, if you were doing this, to draw another triangle. And what we're actually looking for here is we want to know the other sides. We want to know AB and BC. But if you'll notice in all of this, there's not a 4 in there, not even once. Now some of your problems will have the numbers written in there nicely. Others you'll have to do some more figuring. So let's go ahead and draw another triangle. The other thing I would do is, because you notice all these denominators have been rationalized, is I would unrationalize. 1 square root of 5, 2 over the square root of 5. That way we can write our triangle the way it should be written. It will be easier to deal with. So I'm going to keep my angles in the same place. So if my sine of b is 1 over the square root of 5, remember sine is opposite over hypotenuse. So the opposite of b is 1. The hypotenuse is the square root of 5. Now the cosine of b should have the same number on the denominator. So it's now, but the cosine is the adjacent, so 2. And then the square root of 5. And now tangent should follow in opposite over hypotenuse, or opposite over adjacent, 1 over 2. Alright, so now that I have this triangle set up, I need to look at how these triangles are similar. Now you'll notice this is a 4. So how do I go from 1 to 4? Okay, we multiply. So we multiply this by 4. So to get the other sides, we also need to multiply by 4. So this one will be 8, and the top one will be 4 square root 5. Alright, and that's it. Again, your homework will have four parts. Alright, most of them will not ask all these questions. It will ask one question, but I wanted to do it all in one example. So.